All right, here we are going to be naming and writing covalent compounds names. If you remember, I told you that ionic compounds are going to be made of a metal and a nonmetal. So, for example, NaCl, metal, nonmetal, ionic compound. MgBr2, okay, metal, nonmetal. Covalent compounds are going to be made of two nonmetals. Okay, so if we look at this first example right here, we have H, hydrogen, nonmetal, oxygen, nonmetal. Okay, covalent compound. Nitrogen, nonmetal, oxygen, nonmetal, covalent compound. Hydrogen, nonmetal, oxygen, nonmetal, covalent compound. So in order to name a compound, we first have to be able to identify, is it ionic or is it covalent? Well, all of these on here, we would go through and we would figure out all of them are nonmetals, so they're all going to be covalent. And these are so easy to name. What we're going to use is these prefixes, so mono 1, di 2, tri 3, tetra 4, penta 5, and hexa 6. So in this case, I have two hydrogen, so I have dihydrogen. Okay, and how many oxygens? 1. So I use mono oxide. Okay, still the IDE ending just like the anion. So this is dihydrogen monoxide, also known as water. So the next one, I'm going to erase these to give us some room here. The next one, how many nitrogens do I have? 2. So this is dinitrogen. How many oxygens do we have? 3. So I that's trioxide. Okay, so di for 2, trioxide, IDE ending just like before, so dinitrogen trioxide. Alright, so the next one again, sorry, I need some space, I write very large. Okay, 2 and 2, so I know I have dihydrogen. Okay, dioxide, not going to finish writing oxygen because I ran out of space, but dihydrogen for the 2, dioxide. Okay, so this is simple. All we're doing is using prefixes to name these things. Now, the next one. At first you may see that and kind of be like, ooh, what is that? Well, remember those diatomic molecules? Guys, that's just chlorine. Chlorine is always found in 2. So if I'm going to name this, what is it? It's chlorine. Oh, sorry, not chloride. Chlorine. Okay, same thing would be if I saw H2. Okay, remember Brinkelhoff. This is just hydrogen. Hydrogen is naturally found in pairs because it's diatomic. Alright, so second row. Alright. 1 carbon, 1 oxygen. So this is carbon monoxide. You do not have to put the mono on the first elements. Okay, carbon monoxide should sound familiar. This is the stuff that will kill you if you breathe it in. Okay, so we have those carbon monoxide detectors to let us know when we have that around. Alright, next one. I notice that I have 4 hydrogens and 4 oxygens. So, what prefix do we use? Tetrahydrogen. Oops, sorry, I can't spell. And how many oxygens? 4, so tetrahydrogen, tetraoxide. Okay, so hopefully you're seeing a pattern here. I think these are so much easier than those ionic compounds. Alright, now we are going to write the formulas. Guess what? Even easier. Okay, why? Because it tells us the exact number that we have. So phosphide, phosphorus, how many do I have of them? I have 3, so it's 3 phosphorus. How many oxygens? 2. So there's triphosphide dioxide, P3O2. Okay, di. So I have 2 hydrogens. Pentachloride. How many chlorines do I have? Well, penta is 5. So I have H2Cl3, dihydrogen 2, pentachloride. All right, just bromine by itself. Think for a second. All right, Brinkelhoff. All right, so bromine is diatomic, so we know when we see it, it's going to be Br2, kind of like when we just see the Cl2, we know that's chlorine. And last but not least, trinitride dichloride. So 3 nitrogens, so I have N3, 2 chlorines, so that's N3Cl2. So hopefully you guys found the covalent compounds to be a lot easier. I always thought they were a little bit easier to work with as well. So if you need more help, though, remember I need to be seeing you before or after school.